Good morning. This is your stats sensei, Mr. Spensei, and we're looking at a 2005B, question number 2. And this question has a lot to do with combining random variables, expected value and combining random variables. So here we go. For an upcoming concert, each customer may purchase up to 3 child tickets and 3 adult tickets. Let's see, and that's nice of them because they told us C be the number of child tickets purchased by a single customer. The probability distribution of the number of child tickets purchased by a single customer is given in the table below. Compute the mean and standard deviation of C. All right, so the expected value of C is basically going to be 0 times 0.4 plus 1 times 0.3 plus 2 times 0.2 plus 3 times 0.1. And I can go ahead and put that in my calculator by going into stat edit. I go to stat edit, and there's my 0, 1, 2, 3, 0.4, 0.321, stat calc, one variable statistics. My X list is L1, my Y list is L2. The Y list, I should have said my frequency is L2. Those are my probabilities. And I end up getting an expected value equal to 1. So this is 1. My mean here is going to be 1. And so the mean is 1. Oops. And then they also want the standard deviation. Well, the calculator gave it to us, so we know our standard deviation is going to be 1, but we have to show our work. If we don't show our work, we get no credit. So, by the way, this formula is on the formula chart, so we can look that up and go, it's the individual x's minus the mean squared times the probability. I like to think of it the observed minus the expected. Observed minus expected. So here we go. Our expected value is our mean, so our observed is 0. So we're going to start off with standard deviation equals, and we'll come back to the square root in a moment, observed minus 1 times the probability, oh, this is squared, times the probability of 0.4 plus 1 minus 1 squared times the probability of 0.3 plus the observed of 2 minus 1 squared times 0.2 plus 3 minus 1 squared times 0.1. Put that all under the radical, and it just so happened that it equaled 1. So our standard deviation in this case, or the standard deviation for the child, is 1. All right, the next one. Suppose the mean and the standard deviation of the number of adult tickets purchased by a single customer are 2 and 1.2. All right, so the adults are 2 and 1.2. Assume that the number of child tickets and adult tickets purchased are independent random variables. Compute the mean and the standard deviation of the total number of adult and child tickets purchased by a single customer. All right, so let A equal the number of adult tickets and C equal the number of child tickets. Well, the nice thing is we already have the mean of the child, and they tell us the mean of the adult is 2, and we can add means directly. So the mean of the adult plus child equals the mean of the adult plus the mean of the child, which means it equals the mean of the adult is 2 plus 1 for the child equals 3. So that's really easy. So basically the mean of the adult plus C equals 3. Now we also have the child. So we want the A, and we know A plus C, and we know that the child is 1, and the standard deviation for the adult is 1.2. So we have to go 1.2 squared plus 1 squared, all under the radical. And when we do that, 1.2 squared plus 1 squared, we get 2.44 equals the square root of 2.44. So the standard deviation of the adult plus the child equals, raise that to the half power, 1.562. All right, so that would have gotten us full credit on that part of it. Then it says, suppose each ticket costs $15 and each adult ticket costs $25. Compute the mean and standard deviation. Well, we've already defined adult and child, so I'm not going to do that again, because once you've defined it once, you don't need to do it a second or third time. So how many adult tickets? Well, we're expecting to sell 2. So that's going to be $25 times the mean of the adult plus $15 times the mean of the C, which in this case equals 25 times 2 plus 15 times 1 equals $45. All right. I'm sorry, I can't even add this morning. 25 times 2 is 50 plus 15 is $65, not 45. I don't know what I was thinking. All right, I guess I'm probably thinking about tacos. All right, the standard deviation, well, is going to be 25 times the 1.2 plus, because remember, we can multiply standard deviations by a constant, plus we have 15 times the standard deviation that we got above, because this came from up above. Right here, the standard deviation for the child is 1. But the bad news is we have to square them in order to do this. So this has to be under the radical. And I should have a $sign. So 25 times 1.2 squared plus 15 times, well, here, let's do this separately. 25 times 1.2 is 30. I'm going to go ahead and square that. $900 plus, well, now we also have the 15 times the 1, and I'm going to go ahead and square that. And we get 225. Plus the 900, and we'll take the square root of that. And we get 33.54. All right, and if we'd shown all of that work, we should be getting full credit on that one. The explanations for what they're looking for as far as complete work, a little bit sloppy. This is probably going to be the standard deviation of A plus C, but these are multiplied by constants, so we're not going to worry too much about it and go with 33.54. Anyway, I hope that was helpful, and I'll see you on the next one. Thank you.